The next few videos will deal with logical statements. So, what exactly is a statement when you're talking logic as opposed to talking in English? And logic, it is something that is either true or false. And maybe it's easier to talk about things that are not statements. So a question, how are you doing, is not true or false. No, you're asking somebody something. You're not saying that something's true or something is false. You're asking. Do your homework is not a statement. Saying you must do your homework now, that would be a statement. Okay, sometimes you've got a variable in there. That guy went to Harvard. Whether it's true or not depends on which guy you're talking about. A mammal, or that mammal, has 4 legs. Depends upon what mammal you're talking about. So we have simple statements, and these are like the building blocks for compound statements. So a simple statement contains just one truth. I teach. One truth. I am making video. Another truth. Compound statements have multiple things. So I teach and I'm making a video. I've got the 2 parts. I've joined them together by saying an and. I'm saying both parts are true. I'm going to see this movie or that movie this weekend. Now I've said one or the other of them are true. And in logic, as with math, or is by default an inclusive or. So it's possible that I said I'm going to both movies. That's possible. Both parts are true. Now, this is a little bit strange. When you hear compound, you think 2 parts. But in logic, if you have something in a negative sense, it's considered to be compound. So, I'm not hungry is considered to be the opposite of I'm hungry. So, I'm hungry would be the simple statement, and once you put the not on there, it becomes compound. So, what are the joiners that we use in compound? So, or, I've mentioned, says that one or the other is true. Maybe all of them are true, but at least one is true. If you put an and between 2 simple statements, you're saying both of them are true. You say not, you're saying what follows is false. Now there's if-then. And it says if the first one is true, then the second one must be true. But in a logic sense, if the first one is false, we have no idea what's going on with the second one. We don't know. Then we have something called if and only if, and I'll talk about that on the next slide. Or you can have any of these joined together, so you can have 3 parts in a compound sentence joined together. Okay, so what about that if and only if? Not many people actually say that outside of math or logic. They might mean it, but they don't say it that way. Now, if and only if means if the first thing is true, then the second one must be true. And if the second one is true, then the first one must be true. If the first one is false, then the second one is false. If the second one is false, the first one is false. It says the 2 parts have exactly the same truth value. They're either both true or they're both false. Now, we can mean it sometimes, but we just say if then. So, for example, you're about to take the final class. It's the last thing to be graded. You're right on the borderline. And you say, if I get an A in the class, if I get an A on the final, I'm going to get an A in the class. That's true, but probably you also meant if I got an A in the class, it's because I got an A on the final. That the connectivity goes both ways. The implication goes both ways. If I got an A on the final, then I'll get an A in the test. And if I get an A in the test, it's because I got an A on the final. For the people on the borderline. Now, a true if then would be something like, if I get an A on every assignment and test, then I'm going to get an A in the class. Quite true. Now, is that the only way to get an A in the class? No, there's other ways. You could average out to be an A with some of your assignments being B and some of them being high A. So it's not necessary to get an A on everything in order to get an A in the class. We'll say getting an A in everything is sufficient toward getting an A in the class, but it's not required. It's not the only way to do it. And that's really the big difference between an if-then and an if and only if. Oh, and let me back up. I forgot to mention, there are symbols which I did not put in here. An or, the symbol looks like a V, and looks like an upside down V. The not is a squiggle in front of the variable, and if-then is an arrow, and if and only if is a double arrow pointing both ways. Okay, last slide. Quantified statement. So I said some things have variables, and sometimes we're saying that the statement is true for every single thing that the variable could take on. Every mammal has a heart is a universal statement saying it's true for everything. Okay? Some mammals fly. Okay? So, some do. Now, we often in English mean, when we say some do, we imply some don't. And actually, we're going to kind of consider that in here. There are some times that you can't really consider it, but we'll often say that. Okay, none. No human has wings is something that is really a universal negation. No human has wings is the same as saying every human does not have wings. So the every and the none are called universal quantifiers, with the every being in a positive sense and the none being in a negative sense. The some, we call it an existential quantifier. There is at least one thing for which this statement is true.